In this tutorial, we will learn how to run a correlation matrix, or in other words, create a correlation matrix using R, where a correlation matrix contains the inner correlations between a set of variables or of an entire set of variables within a data frame you're working with. So you should see something like this when you open up RStudio. So the next thing we want to do is do File, New File, RScript to open up a new RScript file here. And again, the focus is going to be on creating a correlation matrix in R. So let's make sure that we do a save as here to save the name of this data frame, or rather this RScript file that we're going to be working with. I'm just going to call this test here. It's going to override an existing RScript file. Yes, it already exists. Do I want to overwrite it? Okay. So the next thing that I would like to show you is how to set the working directory, which is part of the initial steps that we always need to do when we're entering a session within R where we plan to read in data and potentially export something or write data or some type of object to our working directory. Now we're going to do both of these things in the data in this tutorial today. So first we want to set the working directory. Mine is actually already set here, as you can see, and this is where the data file I'll access in a second already lives. But if you need to do it, make sure you use either the setwd function with the exact name of your working directory folder and its pathway, or it's an extension to find it on your computer. Mine is my H drive and my R workshop folder here. I can click run to run that line of script here. And we can see if we go to the folder, my H drive R workshop folder, that the data file we're going to be working with is this one, which is Performance Management Reward Systems example. Go ahead and click on that, or I'm going to click on this and copy the exact name of that file because it'll come in handy in just a second. Okay, so you could have set your working directory by doing session, set working directory, and choose directory. That's another way of doing it. So let's read in the data. And if you haven't already, and if you plan to use the reader function, or the reader package rather, reader without an E, all lowercase, to use the read underscore function from the reader package to read in your data, then you would need to use the install.packages function with the name of the reader package within quotation marks as the sole argument within the parentheses. I've recently installed and updated the reader function, so I'm going to use the library function now to access that reader package and its associated functions. So I'll use library, and it's the sole argument, enter reader without an E there as the name of the data frame, or rather as the name of the library or the package with whose functions we wish to access using the library function here. So click run. Okay, so we've now accessed the reader package. So the next thing I want to do is read in the data frame object and name it something that we can then reference later. So we want to name this data frame object. I'm going to name the data frame object PM data, and I'll use the left-handed arrow here to indicate that I wish to name the object that we're about to read in here. And so I'll use that read underscore CSV function that comes from the reader package. If you want more information on how to set your working directory and how to read in data, check out the setting working directories in R tutorial, as well as the reading data into R tutorial, as those provide a lot more information. Now, in the read underscore CSV function as the sole argument, I'm going to, within the quotation marks here, paste in the exact name of that file that I just copied. So that's Performance Management Reward Systems example.csv. And then make sure you add that .csv extension there within the quotation marks. Now let's click run to run that line of script there. And let's click on the name of the data frame here. And you can see we have all these variables here, 11 of them, but really the employee ID variable, it's not really a variable per se, it's a unique identifier. So we'll need to drop that from the data frame if we want to run a correlation matrix over all the variables, because that's going to be meaningless here to have this included in our correlation matrix. And remember that the correlation matrix is used to estimate correlations, which requires some type of numeric data. And notice that our sex variable here is actually looks like it's character, meaning that it is nominal or categorical in nature. And so we have two levels, male, female. Well, we actually need to recode this to make it quantitative in nature. And this is fairly common. We can actually run a correlation with a variable that has two quantitative levels. So let's say 0 and 1 with another variable that has is continuous in nature. And this is called a biserial correlation. And you can run it in the context of a Pearson product moment correlation function, as we'll do today. So we're going to need to change male and female to numeric values here for this variable in order to include it in our correlation matrix. Okay, so let's now go back to our script here, or our script editor. And so let's first start by dropping the employee ID variable. And so as a quick refresher on how you do that, it's quite simple in R. You just name the name of your data frame, which is PM data, $, to say, okay, where does this variable we're about to drop live? Well, it lives in the PM data frame. And so the name of the variable we wish to drop from our data frame is imp ID, or in other words, employee ID. And we need to put its exact name there. And then we use the left-handed arrow, and to the right of the left-handed arrow, we put null. And this is going to remove this variable here from this data frame. So let's go ahead and run that line. Take a look, click on the name of your data frame object in your global environment. And now notice that we don't see the employee ID unique identifier variable there. Well, that's the first step. Now, notice that I also mentioned earlier that we need to recode that sex variable, recode sex to, let's say, female equals 1 and male equals 0. Okay? And so how do we go about doing this? Well, we can also use a relatively simple line of script here to recode the variables. And there's different ways we could do this, but let's recode the levels of this variable using this approach I'm about to show you. Okay, so to do so, do the name of your data frame, which is PM data, or at least that's what we're calling it here, and $ followed by the name of the sex variable, and then enter brackets, because we're about to enter a conditional statement here. And so the conditional statement is going to be, again, name of the data frame, PM data, $, and that sex variable. And then let's do equal to say is equal to, and then make sure we get the case sensitivity right. If we scroll over here, okay, sex, capital S, female, capital F, male, capital M. Okay, let's do female first. So female with a capital F. And because this is a character, in other words, this is text in nature, we need to put this in quotation marks here. And then, so this is our conditional statement. So basically we're saying when the sex variable is equal to female, now enter the left-hand arrow here on the other side of the brackets, to the right of the brackets. And let's put what we want to recode this as. We want to recode it to the numeric value of 1 here. Okay? So go ahead and you can run that if you'd like right now, or you could hold off for a second. So we've run that. And if we look at our data frame object again, we'll see now instead of female, we see 1. Okay, let's copy this. Let's paste below. And now instead of female here, let's put male with a capital M. And we're going to recode, remember, males to 0. Okay, so now it's a binary variable here. So let's run this line here. Click run. Look at our data frame object again, and now you'll see that we have 1s and 0s. 1 being female, 0 being male. So now it's quantitative in nature, or so we think. But we should also make sure that we set the sex variable to type numeric. And this way we can actually use it in a correlation, because sometimes even when we convert it to numeric values, it'll still be recognized as a character or a factor type variable or type of data. And so to do this, just do the name of the data frame, which is PM data, $, name of the variable, sex here. And now we're going to use the left-handed arrow here. And what we're doing here is we're essentially overloading or overwriting the existing sex variable in our data frame. And what we're going to overwrite it with, well, we're going to use the as.numeric function here from base R, and then type in the name of the data frame object, $, and the name of that sex variable. So what we're saying is, here, make the sex variable numeric, and we're going to override the existing sex variable to make sure that it's numeric. Okay, so go ahead and highlight that or put your cursor somewhere on that line and click run. Okay, and so how can we check to see whether this worked after we ran it? Well, we can use the structure or the str function from base R and simply enter within the parentheses as your sole argument the name of the data frame. And so click run. And what you'll notice now is that you see, okay, now everything is numeric, including the sex variable here when we look at the different variables that are in our data frame. Now we're ready to actually create our correlation matrix. So one of the simplest approaches is using the corr function from base R, which is actually the same function you would use if you were just doing a simple bivariate correlation instead of an entire correlation matrix. So in order to use the corr function from base R to create a correlation matrix, all we do is corr, which is all lowercase, the name of the function. And as the first argument, enter the name of the data frame. And so this will, by saying this, we are going to estimate the intercorrelations between all variables, numeric variables within this data frame, and then comma. And our second argument is going to be what type of correlation do we want to estimate? Well, let's use method equals and in quotation marks Pearson to say we want a Pearson product moment correlation. So go ahead and run that line of script. And this isn't the easiest thing to read, especially since it's blown up here, but what you'll get is in the upper and lower diagonals, you have this mirrored correlation matrix here. And so the way you read this is that here you see on the off diagonals, you see 1. So any variable correlated with itself. So here we have perf qual correlated with itself is of course going to be 1. But what if we want to look at perf underscore qual with the association with perf underscore prod? So quality of performance in relation to in relation to productivity. Well, here we can see the correlation here is 0.77, okay? Now, notice that we just get the correlation values here, so the sign and the magnitude, but we don't get any information about statistical significance, the p-values in other words, or the sample size that is used. So in order to do that, we'll actually use a different function, and this one comes from the psych package. And so this is called corr with 2 r's .test. So this is not to be confused with corr with 1 r .test from base R. So this is from the psych package. And so if you haven't already, use the install.packages function and install the psych package, which is all lowercase psych, P-S-Y-C-H. I'm not going to run this line of script here, but maybe you should if you haven't recently installed or updated this package. But I am going to run the library function with the psych package as the sole argument and click run. And this will access the psych package. And now I'm ready to access the corr with 2r.test function from the psych package. And we can copy the exact same 2 arguments from the corr function from base R. So copy those, paste those into the corr.test function. So this is the name of your data frame. This is the type of correlation we're estimating here. And then click run. Okay. And what you'll see here is we have the correlation matrix again. This time this is rounded to 2 decimal places, so it's a little bit easier to read in that regard. And you can see the upper and lower correlations. It's very similar to what we saw before, and you'll see this noted here. This is the correlation matrix. But if you scroll down a little bit lower, you'll see a section that says the sample size. So here it's 95. And in some cases, if you had missing data for some of the variables, you'd get a whole matrix actually instead of just a single sample size variable or value. So it would tell you all the pairwise sample sizes that were used to estimate the correlation matrix. And then finally, you get your p-values or your probability values. And it notes here that the above the diagonal, so the values in the upper triangle here, are going to be p-values adjusted for multiple tests. So you could think of this as being adjusted for family-wise error. Below the triangle, which is what we would typically report, are your standard p-values here. Okay, so you actually have to look at 2 levels of the table here. So if you want to know whether this correlation of 0.77 between perf qual and perf prod is statistically significant, you'd scroll down here to the probability values section, find the same place in the matrix, and we see this is 0.00. This would be less than a 2-tailed 0.05 alpha level, which is a conventional cutoff. And so we'd say, yes, that correlation of 0.77 is statistically significant. Okay. Now, if we want to see the correlation, or rather the confidence intervals, what we need to do is an extra step here. So let's say if we want to see a table with the confidence intervals for each correlation, we can also generate that. And to do that, let's copy this line here. and let's paste below. But to the left of it, let's do our left-handed arrow, and let's create a name for this object. So we're going to create an object, a matrix object that we're going to call, let's say, corr matrix. Okay, so this is arbitrary, but I'm calling this object corr matrix so we can reference it later. So let's click run. You'll notice we have a new object here in our global environment. But why are we doing this? Well, we want to use the print function. So this is print from base R, so print all lowercase. And as the first argument, we want to put the name of this correlation matrix. So let's copy that and paste. Make sure we get it exactly right. And then you want to put in this argument here, short equals false. And what this does is you'll notice down here that there was a little message in our last function. If you want to print the confidence intervals, you actually need the long form of the output for this function. So let's go ahead and do that. So let's highlight and click run. Okay, so what you'll see is the first part of the output is all the same as what we saw before with the correlation values, sample size, and probability values or p-values. But when we scroll down lower, we get the confidence intervals. And you can see the raw and the raw lower, the raw R or correlation values, and the raw upper limits of the 95% confidence interval. And you also get the raw p-values, and you can get the adjusted confidence interval values as well. And so this is a little bit more challenging to read because they truncate the variable names to make this shorter here. But what this says is this is truncated performance quality. So you have to know what your variables are in order to interpret this. This is the performance quality dimension. This is the performance productivity dimension here. And so you can see the dash here, the hyphen, indicates we're looking at the relationship. Okay? All right, so that's how you'd actually look at the confidence intervals using that approach. Now we can also write these to our data, or rather to our working directory. Let's say if we want to write the correlation values, the p-values, or the confidence intervals to our working directory, like we want to open them into an Excel file, well, we can do that by writing them to CSV. So let's do the write.csv function from base R. If you want more information on this function, check out the writing data from our tutorial. So the first thing that we need to do is put in the name of this correlation, this matrix object that we created above, the corr matrix object, and so paste, and then $, and then you'll have to know this is specific to this context, but if we want to write to the object that's from this matrix that is R, so this would be the correlation portion of that matrix, just put lowercase r there, and then comma, and then do quotation marks, and create a name for this .csv file that you're going to write. So let's say that this is correlations.csv. Okay, so this is the correlations here. And so watch what happens if we run this line here. Click run. Okay, it looks like everything worked here. What happened? Well, we need to go to our working directory folder. I'm going to do date modified here to find. And here the most recent thing that just appeared is correlations, what we just named that data file that we read here. And so I'm opening it up now. And so here you can see we've got the different variables. This is our correlation matrix repeated here. Okay, so this is kind of nice, but what if you want the p-values written? Well, if you want to do that, what do we do? Well, just copy this line here. Let's paste it. And actually, let's paste it twice more. Oops. And paste it once more below. And so if you want the p-values, just replace r with p, lowercase. And let's put p-values here as what we want to name the file. You can put whatever you want in here as long as you keep the .csv extension in there. And then the last one we want to write is, let's do ci lowercase for confidence intervals. So let's just type in confidence intervals here. Again, this is completely arbitrary. You could type whatever you want into the name of the files here in quotation marks. So let's run these two lines of script here that we haven't run yet. So click run. And let's go to our working directory folder here. And here we now have a file that's called p-values. Let's wait for that to open. Okay, so here we have the p-values. Now notice that these are in scientific notation. So this is actually telling you the number of decimal points in front, are actually in front of this value here, or rather this value here. or how many points the decimal point is moving to the left, because this is negative here, so it's moving 18. So that's a pretty small value. One little trick you can do here is just change this to numeric in Excel, click it to a number here, and now we have a more traditional way of looking at those p-values here, okay? And then finally, let's take a look at, in our working directory, the confidence intervals, those 95% confidence intervals, that file that we just created. And here, the same thing. You've got your lower and upper confidence intervals. Your p-values are here in this column. Change those to number if you want to put them in, take them out of scientific notation format. All right, so that is how you can create and rather write those correlations, p-values, and confidence intervals from that corr.test function from the psych package. Now, another nice function from the psych package that sometimes makes a correlation matrix a little bit easier to use is just the lower, this is all lowercase, a lower corr rather, there's no dot in there, so lower corr, but there's a capital C. And if you just type in the name of your data frame, as we did before, so let's just go ahead and actually, from the corr.test function, copy these two arguments that are within the parentheses and paste here. So just the name of the data frame and method equals Pearson to see, say, Pearson product moment correlations. Let's run that. And here you'll see it goes over a line, but you'll see that we have just the lower diagonal, just the lower correlation matrix here. This is conventionally what's reported because you don't really need to duplicate values unless for some reason those values in the upper quadrant are adjusted for something. So in this case, it's not. So here, this is a little bit easier to read so we don't have any redundancy in our correlation matrix. Now, one last function I'm going to show you, it comes in handy when it comes to reporting these in a more professional way. So if you're going to report your correlation matrix outwardly and you would like something that's kind of readily formatted in a way that looks professional, I recommend using the apa.cor.table function that comes from the package that's called apa.table with a capital T. Okay? And so this is a really handy function here and a handy package in general when it comes to reporting things in a way that's going to be consistent with APA or American Psychological Association format, which is pretty good for technical writing and includes a lot of useful information so that you don't forget to include it, such as the correlation values, as well as the p-values represented by asterisks, which I'll show you in a second, and the confidence intervals. Okay, so if you haven't already, use install.packages to install the APA table package. So it's APA with a capital T. I'm going to run this, make sure that I've updated this. It's been a while since I installed this, so it's going to run through. Okay. And let's see, here we have an error message here. Let's see if this will actually work. Looks like that the package may not have been updated for the most recent version of R. So let's see if this will actually work though. So, okay, so let's do library, APA, table. Okay. And let's click run. And actually, this might be called APA tables. So let's make sure we get the exact name of the package here. So let's run that. Yes. So the name of the package is APA tables. So I'm actually going to rerun that install.packages line there. So this is where the exact name of a particular function or package rather, and function for that matter, becomes really important. So it's actually APA tables with an S. So important to remember there. I'll add that information here. And then library APA tables to access the package and its functions. Okay, so now we're ready to use the apa.cor.table function from APA tables. And so the first thing that we can do is just enter the name of the data frame we've been working from. So PM data as the sole argument and click run and watch what happens. Well, in our output, we get a correlation matrix that includes the means and standard deviations for each variable that's included in the correlation matrix, as well as the correlation values. And if there's two asterisks, it means its significance at 0.01, so the p-value is less than 0.01. If it's one asterisk, Let's see if we have any of those. Yes, here it means it is significant if p is less than 0.05, and it doesn't have an asterisk next to the value. It means it's non-significant. Okay, and then the brackets below each correlation value are the 95% confidence intervals. So this is the confidence interval here for this correlation value. Okay, now what if you want to write this to a Word doc? If you want to write this matrix to a Word doc so you can then manipulate it, well, all you have to do is add this argument here. So after your data frame name, just type in quotation marks and then come up with some name for the document. So I'm just going to say APA correlation table. Okay, and make sure you put .doc, not .docx, but .doc here at the end. Okay, so go ahead and run this. Okay, so it still gives you output here, but now let's check our working directory folder. It should have written this. And so now we have APA correlation table. We just created this. Let's open it. Wait for it to open here. And now we have a pretty nicely formatted, and you can adjust this, the axes or the columns like you would in any type of folder or any type of table that you have in Word. And notice that it spills over a little bit here, but you could probably adjust the margins here. So let's do margins at 1/2 inch. Okay, so now we barely squeak this in here. At least most of the table, we're still missing a piece of it here, but we can slide this over here and get an idea at least what this correlation matrix looks like. And it even includes a note here in terms of how to interpret what's in the table. So this is a really handy way to make a quick APA style table. I know this saves me a lot of time to use this, and then you can just easily manually override and rename these variables something more meaningful that an outside audience would understand. Okay, so that is kind of a review of different ways in which you can access and create correlation matrices using R. There's other ways that you could do this, and in this tutorial I don't show you how to use the heat maps, but in the psych package there is a way to create heat maps, and you should check out a written tutorial if you'd like to see how to create a heat map matrix of correlations. Thank you very much.